So, in this video, I am discussing remaining 15 problems of Grant estate. So, here, when points A and B are maintained at same temperature, let us say theta 1, theta 2, it's similar to the Wheatstone bridge in current electricity. When bridge is balanced, so here it is R1 by R2 is R3 by R4. No current flows through this. So here we have four different rods. So resistance of each rod is equal to L by K. Same dimensions. Suppose if I take its resistance as R1, its resistance as R3. R1 by R3 is same dimensions he told. That means length and area are same. Change occurs only in coefficient of thermal conductivity. That is L by K3A. A get cancelled, which is K3 by K1. Similarly here, this one is CB, its resistance is R2, here resistance is R4. R2 by R4 is L by K2A by L by K4A, which is K4 by K2. So from this I can say K3 by K1 is K4 by K2. That is K1, K2 is equal to, here it is K3, K2 equal to K1, K4. So K3 by K1 is equal to K4 by K2. Third option is correct. Here, an open argon pipe here, L is 2 times lambda by 4. Velocity of sound, which is equal to V is N into lambda, which is 2L. The frequency is V by 2L. How velocity and temperature are related, V is proportional to 2. Here, L is fixed, V proportional to N. That means frequency is proportional to temperature. N1 by N2 is root of T1 by T2. Now, T1 we have to take in absolute scale. So we add it, which is 300. So it is filled with a gas, same gas at 90. Then T2 will be 273 plus 90. We get 363. Initially, resonance frequency at 400 Hz by N2, which is 300 by 270, 363. 300s, 121s, 10 by 11. Get cancelled. N2 will be 440 Hz. Here, certain atom, when electron moves from 4e to e, so here photon is released in that process some energy. So that energy is hc by lambda, which is 4e minus e. Let us say it has that photon of wavelength lambda 1, which is 3. Say this as one equation. The wavelength of photon produced during its transition 7 by 3e to e. So when electron of an atom when moves from this energy level to this energy level, when it emits a photon of wavelength E2, 7e by 3 minus e, which is 4e by 3. Now divide one with other, Hc by lambda 1 into lambda 2 by Hc, which is 3e by 4e by 3. So lambda 2 by lambda 1 is 9 by 4, which is 4 by 9. Here, coefficient of linear expansion of inhomogeneous. It's not homogeneous, so rod changes linearly from generally if it is a homogeneous rod, in this strip there is an extension this much. If you take another strip here, of same dx length, but there is a change will be different. The earlier change is only this much, now change is different. So it is inhomogeneous rod. So alpha keep on changes from alpha 1 to alpha 2. So at this point expansion is alpha 2. Linear means in a straight line how it changes at this point when x is 0, length of the rod, let us say it is L, at x is L. At x is 0, alpha 1 is the coefficient of linear expansion. At x, L, coefficient of linear expansion is alpha. So this is theta. Here 0 alpha 1. Here it is L alpha 2. So at some point I say x alpha. So here tan theta is alpha 2 minus alpha 1 by L1. At arbitrary point, alpha minus alpha 1 by x minus 0. So from here alpha minus alpha 1 is alpha 2 minus alpha 1. So here linear in a straight line. That is what the meaning. So here alpha will be alpha 1 plus alpha 2 minus alpha n by x. Now here the effective coefficient of linear expansion. So now where at which strip, how it changes, we don't know. Dx length, when it changes as this like this, this I will say it as dx dash original length dx dash equal to dx into 1 plus alpha delta t, or dx dash minus dx into alpha delta t. So the small strip, this is extension in the small strip, that is delta L dx into alpha delta t. So this is only change in the small strip. Throughout the rod, how it changes, that means integral dl 0 to L. So 0 to L, alpha here is alpha 1 plus alpha 2 minus alpha 1 by n. So it is right. So this temperature is fixed. Here I'll use some space. Resin temperature is fixed. So I can take dt outside. 0 to L alpha 1 dx plus 0 to L alpha 2 minus alpha 1 by L x dx. Integral dx is x between 0 to L. Integral x is x square by 2 between 0 to L. Alpha 1 L by 2 L here, which is L alpha 1 L common alpha 2 minus dt into alpha 1 plus alpha 2 by 2L. Integral dl is, that is total change in length. So delta L finally, right, which is equal to L alpha 1 plus alpha 2 by 2 delta T. This is L alpha effective. So alpha effective is this. That is second option. Here in this case, when cylinder rolls up an inclined plane, rolls down without slipping. Without slipping means V equal to R omega. So when it is rolling up slowly, its velocity, translational velocity, decreases. So to maintain pure rolling, once velocity decrease, omega also must decrease. So here omega decreases when frictional force acts on this. So frictional force must provide torque in such a way that it must reduce angular speed. So here, to reduce angular speed, friction must act in upward direction. So that friction acts in this direction, it rotates in anti-clockwise direction, its angular speed decreases. In other case, so when it is rolling down, translational velocity V increases. For pure rolling, V increases, so omega must increase. When frictional force acts like this, so then obviously angular velocity increases and it supports pure rolling. So always up the plane or down the plane, friction act upwards. Here, solid sphere rolls without slipping. So without slipping means suppose minimum friction must be there, otherwise pure sliding occurs. For rolling, so minimum friction is there. That minimum friction is tan theta by 1 plus r square by k square. All of you must remember everywhere generally k square by r square. While calculating friction, we write r square by k square. For a solid sphere, moment of inertia formula m into k here, radius of gyration, r square by k square is 5 by 2. So then mu becomes tan theta by, that is 2 by 7 tan theta, which is k by 7. So k becomes 2. So here it is. Once particle is moving in a circular path, so it may be uniform circular, non-uniform. Uniform circular means only centripetal acceleration will be there. Non-uniform, there is a change in the magnitude of the speed. There is tangential acceleration as well as centripetal acceleration. So you will have a resultant acceleration. The total acceleration is AC square plus AT square. The total acceleration makes an angle theta with the tangential, then tan theta will be AC by AT. So, but he given only constant tangential acceleration, that AT he given 3 meters per second square. To calculate centripetal, we have to write a formula that is mr omega square. He given radius, so I can write 4m, but what we want is omega. Once it is making revolutions, its angular velocity changes. So initial angular velocity is this, but he is asking acceleration at 2, that is 2 alpha. So alpha can be found by using tangential acceleration has a formula. Radius is alpha here is 3 by 4, 2 into 3 by 4, we get 3 by 2. Now centripetal acceleration is 4m, omega square is 9 by 4. Now tan theta is AC by AT. AC here is 9 by 4. AT is 3, which is 3 by 4. That is tan theta value. Next question here. A uniform rod of mass m and length L with an insect of mass m by 3 here it is with an insect of mass m by 3 initially placed at here. Here system means rod plus insect is system. When insect moves towards left or right doesn't matter. So no external torque. That means torque 0 means dl by dt 0. L becomes constant. When L is constant, angular momentum is conserved. So generally momentum means mass in place of mass, moment of inertia in place of velocity, angular velocity. I1 means initially if it rod rotate about an axis from one end, moment of inertia is ml square by 3. Here is an insect of mass m by 3 that is at L distance, L square. Omega 1 he given 5. Now when insect comes here at the middle, it is L by 2. Rod moment of inertia is same, but insect moment of inertia m by 3 into it is at L by 2 distance now. So from here 2 ml square by 3 into 5 ml square by 3 if you take common 1 plus 1 by 4 omega. This get cancelled. 5 by 4 omega 2. So omega 2 here is 8 radians per second. So another one, a coil having 100 turns and area 0.01 meter square, free to rotate about an axis. So when coil is placed in a magnetic field, there is some flux. That is, if there are n turns, So here coil is placed perpendicular to the magnetic field. So here magnetic field direction is this. Coil is placed perpendicular to it. Area vector is always perpendicular to the plane. That means angle between B direction, A direction are parallel. Theta is 0. N here is 100. BA cos theta. D he given 1 Weber per meter square. Area 0.001 cos 0. So 100 into this is 0.1. This is initial flux which flows through the coil. If the coil is rotated rapidly through an angle 180 degrees, so then like this, when it is rotated 180 degrees, right, area vector is this, flux is this, here angle is 180 degrees, and flux will be NB dot A 100 BA cos 180. So here it is 100, B will be 1, area 0.001 cos 180, it is minus 0.1. Change in flux, you get it as minus 0.2. So here EMF induced is minus d5 by dt minus d5 dt. And here V is E by R, that is 0.2 by resistance 10 ohms given into dt. V here is, this is I. So I dt will be 0.2. I dt is nothing but charge. So Ti by rate of flow of charge is current. So I dt will be Q, that is 0.2 coulombs of charge, right, will flow through the coil. Here, a solid sphere of radius r changed uniformly. Electrostatic potential at a point is half the potential at the center. So electrostatic potential, even gravitation, there solid sphere. Here also, this is very important. Solid sphere. So potential will be 3kq by 2. This is at the center. At center of solid sphere, not hollow sphere. You must be careful. Solid sphere. So here from center at a distance x, at this point, potential is kq by x. Now what he given is electrostatic potential at any point is half the potential at the center. So here 3x is 4r. This x is asking distance from its surface. So this is r. X will be r plus y is 4r. Y is distance from the surface. So y here is R by 3. We given it as R by K becomes 3. But I think 4 get cancelled, it is only 9. So 3. So theta here is tan inverse 3. So here Young's double slit experiment, fringes are displaced by a distance x. So here slits in the path when glass plate is introduced, fringes shift by uh, glass plate of refractive index is introduced, it displaced by x. So that fringe shift formula we have beta by lambda, where beta is fringe width, which he given it as x. So let us say this is mu1. When the plate is replaced by another plate of same thickness, so new shift will be same thickness he told, maybe refractive index, plate change and refractive index change, that is 3x by 2. So divide 1 with 2, we get beta by lambda into x by 3x by 2, which is 2/3. 3 times mu minus 1 is 2 times mu1 here is 1.5 minus 1. So which is 1.5 minus 1.5, 4.5 by 2, which is mu2 minus 1. 1 plus 2.25. Sorry, this is 1.5. So 1 plus 1.5, mu2 will be 1 plus 15 by 20. It is 1.75. That is refractive index of light. Here an ideal spring with spring constant is hung from the ceiling, and the block of mass m. Hold this block m, and if you release slowly, then we write mg as kx, x as mg by k. This is slowly. So without holding, just release it faster, then the extension will be different. So in the process of fast release, total energy gained here is, that is elastic potential energy which is stored in the string. So here there is a loss of potential energy. X will be 2 mg by k. In place of m, Answer is there is a difference between slow release and fast release. Here 4 cos pi t plus 4 sin pi t, it is of the form a cos omega t b sin omega t. Amplitude will be, let us say, ab root of a square plus b square. 16 plus 16, 4 root 2. K root 2 he given. K value is 2. In Bohr model hydrogen atom, single electrons rotates around the nucleus in a circle of radius, makes this many revolutions each second. Frequency will be how many times it is making revolution. For each revolution, it covers this much angle or just frequency, that is enough. Frequency is number of revolutions per second. That is such. So magnetic field at the center, once it moves in a circular path, your current through it is rate of flow of charge. So mu naught by 2, and time here is 2 pi by omega. 2 pi by omega is 2 pi n. That is frequency 6.6 into 10 power 15. So here, to calculate current, charge of electron, so time period is t here is 1 by 6.6 into 10 power 15, 1.6 into 10 power minus 19, 6.6 into 10 power 15. So mu naught I by 2, here it is 1 minute. Four pi into 10 power minus 7 by 2. I here is 1.6 into 6.6 into 10 power minus 4. By radius is there. Radius is 53 into 10 power minus 12. So 4 pi 4 pi into 1.6 into 6.6 by 106 10 power minus 11 plus 12, 1. It is 4 into 3, 12. 12 into 1.5, 18. 18 into 6, 108. Little more, maybe around some 1.2. After simplification, you get some 12.5 Tesla. Here, current of 4.8 amperes flowing through the conductor. The number of electrons per second. So 1 ampere current is nothing but 1 by 1.6 into this many electrons flow. 4.8 amperes current means 4.8 into this many electrons, that is 3 into 10 power 19. So K value is